to you. Okay, it can look pretty intimidating, but if you use the technique that I teach you, okay, it's really straightforward. There's nothing intimidating. Okay, right. So we are going to solve this problem. I'm going to copy this, and so that we know what's the value. So what we are going to do is we are going to sketch 3D mold, or we are going to properly draw, not sketch 3D mold circle now. Okay. So I'm going to incorporate the U strength into this 3D mold circle, and that will lead us to our fracture or ductile failure for next week. Okay. So this will be at minus 200, 180. I hope for today's lecture, the network is better than what we had last week. And I think last Thursday, we were affected by what happened to Microsoft, right? It crashed. Okay. 0, 20, 40, 60, 80, 100, 120, and 140. So this is normal stress. 140, okay. And then we have shearing stress. So this is our shearing stress. This is clockwise. This is anti-clockwise. 20, 40, 60, 80, minus 20, minus 40, minus 60, minus 80. I'm going to follow this by sketching a red box. Sketching a red box. So I'm going to sketch the red box. So the red box will go up to the shear of 73. Okay, so I'm going to eyeball 146 and 73. So this is just a sketch. So 73 is about here. And that is, then I'm going to sketch up to 146. And the 3D mold circle has to be inside this red box. Okay, I repeat again, the 3D mold circle has to be inside the red box. Okay, so if any part of the circle is outside this red box, okay, it will fail. So over here we have 73. Right, this is our minus 73. And this is our 146. And this is our 146. Okay. So if the circle, okay, is outside, the structure will fail. It all has to be within the red box. So the 3D mold circle has to be within the red box or the red rectangle. If outside, if any part of the 3D mold circle is outside the straight rectangle, the structure will yield, okay, which we don't want that to happen. Okay, so let's from here, if we look at this box over here, okay, so this is our, again, this is our point X, this will be our point Y, and this will be our point 0. And rightfully now, we know that over here, this is where our point Z is. Okay. The only information we have is our point X. Okay. So I'm going to sketch, or we're going to point out the location of our point X. So it's at -50. Right, and then the shear is at 48. So I'm going to sketch 48. Let me draw the, so this is 48. And I will draw another one. This is our 48. And looking, so this is our stress X line. And then if we put our finger on the center, right, X will do a anti-clockwise rotation. So we know that this is our point X. Okay, that is our point X. So the next thing that we want to know, okay, what there is a, we know that our tau max, no, okay, we know that tau max, I'm going to write this over here. We know that tau max, right? Tau max is given to us at 73 megapascal. Yeah, you know that it's going to be at 73 megapascal. Okay. So we want to find where is our point Y. Okay. So there are two possibilities. Okay. So what are the two possibilities? So one of the possibility, okay, it dependent on our average shear stress. Okay. So one of the possibility, now I'm going to sketch. Okay. And I'm going to sketch in orange. Okay. So one of the possibility is we have our stress average, okay, is at this point. Okay, this is just a sketch, by the way. Okay. Okay, so one possibility is over here, this distance from here to here, because we know this is our radius. Okay, over here, this is our tau max. Right. So one possibility is over here. This is our Y1. Okay. The other possibility, and this is when it intersect the zero shear stress, this is our 0, 1, O1. Okay. And then there's another possibility. Right? And this is our the other possibility. And over here, the other possibility is this is our Y2 or Y1. Okay. So one possibility that another possibility that this is our Y1. And you will realize that, oh, sorry, I'm going to call this Y2. I'm so sorry. And already now you see Y2 is outside the box, right? So you know when we calculate Y2, that value is not possible because it's outside the red box. Okay, but now we are learning. Okay, so this point over here we intersect. We're going to call it our O2. Okay, so from here we can determine our O2, O1 and O2. Okay, so how about do we do that? It's purely strictly geometry. Okay, so we are going to calculate our average, or we are going to calculate our center of circle, which is our stress O1 and stress O2. And this is equal to minus 50, right? Minus 50 plus or minus square root. So it's equal to 73 squared minus by 48 squared. So this will be equal. Why 48? Because what we are trying to determine, if we were to have this, okay, so the green line that I'm going to draw, that's where the average stress line is. Right. It really does that. Right. So what we are trying to determine, so this distance over here, this distance that I'm going to, and this distance are the same. And this distance is calculated based on square root 73 minus by 48 squared. Likewise, this distance is 73 squared, right? So when we get this, so minus 50 plus or minus 73 squared minus by 48 squared, square root of the whole thing is 55. Okay, so this can be equal to minus 105 megapascal, or it can be positive 5 megapascal. Okay, so if we want to calculate stress stress Y1, so we are also aware that this distance here to here, this distance is also equal to 55. And the distance from here to here is also equal to 55, because this 73 squared minus 48 squared is equal to what? 55. So from here we can calculate stress 1 or stress Y1, which is equal to 5 plus by 55 and is equal to 60 megapascal. and stress Y2 is equal to minus 105 and minus 55.